In today's lesson, I'm going to do a few problems from the previous lesson so that it will be a quick recap on the concepts which we covered. So I'm going to start with question number 5 and 6 on page number 540 from your textbook, which is IB MYP 5 second edition, and it's in Manage Bag. I think it's in the Google Classroom as well. Okay, so first question we are doing is find the coordinates of the point or points on f of x is equal to x squared plus 3x plus 5 where the tangent is horizontal. So this curve is with parabola which is opens up, so I don't know exactly and I'm not going to draw. So let's say the sketch is something like that. So the tangent is horizontal is here, and when the tangent is horizontal, which means the derivative of, you know that derivative of a horizontal line is 0, so derivative is equal to 0. So we know how to find the derivative. So f prime x is equal to 2x plus 3. So this 2x plus 3 is equal to 0. So 2x is equal to negative 3. So x is equal to negative 3 over 2. Now we need to find the y point of this function. So to find the y function, you need to substitute x is equal to negative 3 over 2. Negative 3 over 2 into the calculator. X is equal to negative 3 over 2 into the calculator. So negative 3 over 2 whole square plus 3 into negative 3 over 2. So you can put it into calculator. So negative 3 over 2 plus 5, and then you will find your y value. When you substitute this will come out to be 11 over 4. Okay, so this is your y coordinate of question number 5a. So the next one is equal to so to find out, you can do to find the y coordinate, you can do by substituting, or you can use calculator if you want to save some time. So what you can do here is you substitute y1 and you write down this function as x square. So this is x square plus 3x plus 5. And now since we need, something is wrong, so we need here delete. So we needed x square plus, okay, so it seems like I have to enter this again. Okay, so x square plus 3x plus 5, and then you go, because you need the value for when x is equal to negative 3 over 2. So what I can do is I can start my table set at a negative 3 divided by 2, and then you can see from second table the value is 2.75, which is your 11 over 4. So that is how you can use calculator. So I won't be showing this for each and every question. Either you substitute it by hand, or will be a good practice, or you use calculator to find the y coordinates. Now the next one is f of x is equal to square root of x where the tangent has gradient half. So now you know how to find the gradient here. So first step, whenever you have a radical sign, change it into exponent form. And now f dash x is equal to 1 over 2 x raised to power 1 over 2 minus 1. So 1 over 2 x negative half. Now we know this is not only the derivative of a function, the general rule for f of x is equal to square root of x, but it is also the gradient of the tangent. But the gradient of the tangent in this case is half, which means 1 over 2 x minus half is half. Half and half get cancelled. So this is 1 over square root of x is 1. Cross multiply. When you cross multiply, 1 is square root of x. So x is equal to 1. Now you substitute as x is equal to 1 in the given equation, and you get 1 comma 1 as a point. Okay. Now the next one, same thing. Gradient is 1, the function is different, so it's again good practice of how to find the derivative using the rule xn, which is nxn minus 1. So this is 3x square, this is 2x, derivative of 1 is 0. So you get 3x squared plus 2x is equal to f dash x. Now this is equal to 1 because this is the gradient of the tangent as well. Now, so this is 3x plus 2x is equal to 1. It's a quadratic equation. So you can either, if you can factorize, you can find the values of x using factorization, or you can use discriminant rule, or you can use the calculator for this one. So let's have a look. How do we use the calculator here? So you go to no, it's not in mode. You go to apps, and then you go to, this is quite a useful application, PLY SMLT2. And now we are trying to find the polynomial root finder, and it's a quadratic. So 3x squared plus 2x minus 1, which means order 2. We are not changing anything, and then go to next. And now you enter this, the equation was 3x squared plus 2x minus 1. So 3x squared, and then you enter 2x. Okay, sorry, you need to enter 2 here, and then you need to enter -1. So -1, and then enter, and then you solve it. So this should give you the values of x1 here. So in this case, you got x1 1/3, and then next one is -1. So at these 2 points, the tangent of the gradient will be the gradient of the tangent will be 1. And now same way, you substitute back when x is equal to 1/3. When you do the calculation, this will be minus 23/27, and -1 will be -1. So this is how you find the points here. Okay. Now the next one is when you have f of x, again the same question. So only the f of x is changed. So this is 3x squared minus 3, and this gradient is 9. So 3x squared minus 3 is equal to 9. 3x squared is 12. X squared is equal to 4. X is equal to plus minus 2. So for 2 and for -2, so these are the 2 points where the gradient of the tangent is 9. So when x is 2, you again go back and substitute in the given function, and -2 in the given function. When you do this, it will be 3, and this is going to be -1. Okay. Now the next one is instead of you have all the values of the coefficients, now we have a, b, and c. So what we have to do is, f of x is this, where the tangent has 0 gradients. So let's have a look what we can do in this case. So here, ax squared plus bx plus c, this is equal to, and the derivative in this case is going to be 2ax plus b, and this has 0 gradient, which means this is 0, and then you get 2ax is equal to -b, x is equal to -b/2a. So your answer for x will be in terms of a and b. There is no way you can find a and b. There is no other condition given. And now you will go and substitute here. So this you cannot use calculator, so I will show you how to do by hand. So this is this, b into, use bracket, because whenever you have negative number or negative expression, always make sure you use brackets. So this is your y coordinate. So y, remember f of x is same as y. So this is a, because it's whole square, so this becomes a b square over 4a square minus b square over 2a plus c. So you got here ab square over 4a square minus b square over 2a plus c. Okay, now we can simplify this. So let's try to simplify. So 1a got cancelled. So this is b square over 4a minus b square over 2a plus c. Now for this one, you can make the same denominator, and then you can see b square minus 2b square over 4a. This gives you minus b square over 4a, c minus b square over 4a. So that is your and you can do further 4ac minus b square over 4a by making the denominator of this also 4a. So this is your y coordinate here. Okay. So the next one is find a if f of x is ax squared plus 6x minus 3 and it has a tangent with gradient 2 at the point where x is -1. So ax squared, so let's say that I don't know a is positive or negative. So if let's say a is positive, then the curve is like this. So it has a tangent with gradient 2 at the point, so where x is, let's say, -1. So here the slope is, so okay, I can see that this is not correct because this gives you a negative slope, so maybe a is negative. So then the gradient is 2, so it's just a rough sketch, may not be correct. So the gradient of this is, they are saying is 2. What you need to do is you need to find the value of a. So let's have a look. So this is 2ax plus 6, and this is equal to 2 when x is -1. So 2a into -1 plus 6 is equal to 2, minus 2a plus 6 is 2, minus 2a is minus 4, and then you got a is equal to 2. So your a is 2 in this case. Okay. Now, similarly, the next one, you have f of x is a over x has a tangent with gradient 3, where at the point x is equal to 2. So now again, before you start, remember we cannot have anything in the denominator because we do not know sufficient formulas at this point. Once we'll do little more about this maybe next year, then you will learn more formulas here. So f dash x in this case is a into -1 x raised to power -1 minus 1. So minus a x raised to power -2. So this is minus a over x square, and this is equal to 3, but when x is 2. So minus a over 4 is equal to 3, which means a is equal to -12. Okay, so minus a is 12, and which means a is -12. Okay. Now I'm going to also do another question, and I'm going to introduce kind of a new thing, which is the equation of the normal. You already know how to find the equation of the tangent, but I'm going to review that as well. So find the equation of the tangent and normal to y is equal to 2x square minus 3x plus 7 at x is equal to -1. Before I start, before I will start doing the equation of the normal, I want to quickly recap one thing. So if you look at this line, this has an equation y is equal to x, and let's say the slope of y is equal to x is m1, and then this is the line, and this is the equation is y is equal to -x, and let's say slope is m2. So in this case, m1 is 1 and m2 is -1. And now let's look at y is equal to x means this angle is 45, this angle is 45, this angle is 45, which means these two lines, they are perpendicular to each other. And please notice that if they are perpendicular to each other, if two lines are perpendicular, for perpendicular we use this rather than writing PENDIULAR. So we write down the lines, two lines are perpendicular, then the relationship between their slopes is m1 multiplied by m2 is -1, or m1 is -1 over m2, or m2 is equal to -1 over m1. So the slopes are, how do we say it? Reciprocal and opposite. So you can't say negative here, because sometime the slope of this, if slope of this was positive, the slope of the line was negative here. Okay, but if the slope here is negative, here the slope is positive. So what we have to do is reciprocal and opposite. Now I'm going to start with finding the equation of the tangent, and you already know the steps. So we know the step number 1 for equation of the tangent is point of contact. We already have that point of contact. No, we have x point. So x is -1. I'm going to substitute here. When you substitute x is -1, let's have a look. So 3 -1 plus 7. So you got 2 plus 3 plus 7. So that is 12. So we got 1 comma 12 as the, -1 comma 12 as the point of contact. After that, we'll find y dash, step 2. So this is 4x minus 3. And then we will find that y dash when x is -1. So 4 into -1 minus 3, that gives you -7. So we have the gradient now. Now we are ready to write down the equation, which is y is equal to -7x plus c. This is the equation of the tangent. Okay. Now for this one, how do we find c? We substitute the points here. So this gives you 12 minus 7 into -1 plus c. So 12 is equal to 7 plus c. So c is equal to 5. So equation of the tangent is y is equal to -7x plus 5. Okay. Now to write down the equation of the normal, I'm going to just draw. So if I have this curve, let's say this is the curve and this is the point and this is the tangent. Tangent is a line which has only one point of contact with the curve, and this is normal. Okay. So this is normal. So normal is again a line which is perpendicular. So this is perpendicular to tangent. Okay. So once we know the equation of the tangent, the equation of a normal is very easy. And pay attention to this point is common. This point is on the curve. which we got in this case was negative 1 and 12. So this point, let's say, is negative 1 comma 12. So this point is on the curve, this point is on the tangent line, and this point is also on the normal line. Okay, so this is the point which is common for all these three. So now I have to write the equation of the normal. For equation of the normal, what happened is, we know the slope of the tangent. We got here the slope of this was negative 7, which means the slope of normal is going to be 1 over 7. Remember, reciprocal. When you do reciprocal of negative 7, you will get 1 over negative 7. And then you will take the positive side here because it's opposite. So 1 over 7 is the equation of the normal. So is the slope of the normal. So the equation of normal is going to be y is equal to positive 1 over 7x plus c. Now to find c, you will again substitute the same point. So 12 is equal to 1 over 7 negative 1 plus c. Solve it for c, you will get your equation of the normal. I hope this is clear. I'm going to do another example so that you can see the steps again. So we have this function, and I'm going to first, because we don't need anything in denominator. And here the best thing is that the point of contact is given. So our step 1 is skipped because step 1 is given. So we don't have to worry about that. In the previous one, what is the difference between these two? Obviously the function is different, but here only x coordinate was given. So we had to find y also to find the point of contact. Here the point of contact is given. So now we will simplify. So we know when we have more than one term in the numerator and only one term in the denominator, we can separate them. So this is 2x minus 5x minus 1. So this is your y. Now we need to put y dash, which is equal to 2 minus 5 into negative 1. X is this, which is equal to 2 plus 5 over x squared. So this is our y prime. Okay, once we have y prime, we need to find y prime at x is equal to 2. So y prime at x is equal to 2 is 2 plus 5 over 4, and that is going to be 13 over 4. So that is my y prime. And remember, this is also is the gradient of a tangent at x is equal to 2. So now we know the equation of the tangent is going to be, y is equal to 13 over 4x plus c. And to find c, you substitute this point. I am leaving this so you can complete this step in yourself. Now I'm going to do the equation of the normal. So what is the difference? In equation of the normal, it's same thing, but instead of 13 over 4, you will have negative 4 over 13x plus c. And then you substitute the same point and you will find the equation of the normal. Okay, so I hope that it is clear, and this is going to be your homework. So this is your homework. I'm going to so you will need to pause this video and then make sure that you don't have to copy down the statement, but you have to write down f of x is this and what is f dash x. So first two question is just using the rule x raised to power n, but obviously you have to simplify the second one. The third and fourth is using first principles, and fifth one is finding the equation of the tangent and normal. So this is all for today's lesson, and this is the last lesson for this year. And we could, like, it's not everything which you will study in introduction to calculus, but we had a good start, and then next year you will learn more about more differentiation rules as well. But I think this should give you a solid base to start in DP. So that's it. This is as I said, this is the last lesson for this year. Okay, I hope it's clear. Thank you.